Hello. First of all, I am pleased to represent this course on designing water treatment and desalination systems. And in the beginning, I'd like to introduce myself to you. I am Chemist Mukhalil, a specialist in the field of water treatment and desalination for more than 10 years, working in North of Africa and Saudi Arabia. I am ex-water treatment projects manager and currently I am bidding and tendering engineer in Saudi multinational company. Also, I am certified project management professional at the American Project Management Institute, the BMI. I hold a number of certificates for completion courses in various fields such as CAD drawing softwares, project management, operation control and operation quality. And it's a pleasure to represent this course in the field of designing water treatment and desalination systems, and I hope that this course will meet your expectations and you will benefit from it in improving your design and operational skills of water treatment and desalination plants. The course is divided into 5 sections. Each section is concerned with a specific water treatment system. In each system, we will talk in details about the principles, guidelines, and calculations for that system design, with examples given for these instructions and calculations. Section 1 will be focused on sand and multimedia filter design. The second section will be related to the systems of removal iron and manganese ions from water with oxidation by different methods, precipitation, and filtering through perm or green sand filters. Section number 3. In this section, we will discuss the steps of designing water ion exchange softening system for removal of total hardness or hardness of calcium and magnesium through ion exchange resin media. Section number 4 is focusing on instructions, guidelines, and calculations of designing the ionization process through ion exchange cation and anion resin. This system is called deionizers, whether this deionizer is 2-bit deionizer or mixed-bit deionizer. Section number 5 will be specific for reverse osmosis and nanofiltration system design. Now with a quick overview of the content of each of the 5 sections in this course. The first section is the section on designing sand and multimedia filters. In this section, we will first learn about some important physical and chemical properties in the field of water treatment and some terms and expressions that must be known before proceeding to study the details of the design steps, whether in this section or the sections we deal with in the course or other systems in the field of water treatment. Also, a quick overview at the types of impurities and contaminants in the water and their impact on health, methods of measurements, and treatment methods. Then we will start learning the steps of designing sand and multimedia filters. We will learn what is the importance of the filtration rate and how it can be calculated and determined, and we will calculate the dimensions of the filter, its diameter and height, and the other specifications of the filter vessel or tank. We will learn what is the relationship between the filtration media layers depth and the media grain size of each of these layers and the importance of this relationship in determining the quality of the water produced and the cost of installing the filter. We will also learn how to calculate the amount of the filtration media, whether in liters or kilogram. We will know what is required about the process of backwashing, the rate of expansion of the media during backwash, and the precautions required in the design for the success of backwashing process. We will also learn how to choose the right control system and distributors system for our design, piping size calculations, and plumbing connections for the filter. In the second section on designing systems for removing the elements of iron and manganese, we will explain in the introduction the difference the different forms of the elements of iron and manganese in water, their sources, and the acceptable limits in drinking water. We will discuss the best methods of removal of iron and manganese and how these methods affect the cost and quality of water produced. After that, we will learn all the processes, calculations, and design guidelines for iron and manganese oxidation, precipitation, and filtration. We will calculate the amount of oxygen or chemical oxidizing agents required to oxidize the iron and manganese, and the time to complete the oxidation process. Finally, we will learn how to design perm and green sand filters in terms of the amount of media, the specifications of the vessel and its dimensions, the diameter of the vessel and the depth of the media layers, and the specifications of the control system and the distributors. In the section on designing a water softener, we will study the total hardness and its source in water and the acceptable limits of calcium and magnesium hardness in drinking water and industrial water. And we will talk about the effect of hardness on equipment, pipes, and plumbing fittings, and its effect on skin and human health. We will explain an introduction on the different ways to remove hardness, and then we will start detailing each stage of the design of the softener system and its regeneration system. Calculations determine the amount of resin required, instructions for installing the resin, and specifications for the vessel, and calculating the dimensions of the vessel, the diameter and the height. Calculations for determining the required amount of regeneration material, stages of regeneration process, and its accessories. Finally, the softener control head design and the specifications of regeneration brine tank. In this section, we will talk about two-bed and mixed bed deionizer design. We will explain deionizer applications, when we should use deionizer and when using deionizer is not the best solution. Also, we will discuss advantages and disadvantages of using deionizers. Further, we will learn about deionizer design. We will start with learning about the different measuring units of total dissolved solids or TDS and how TDS is used in calculating the required resin quantity in both cation and anion vessels. After determining resin quantity, we will learn how to determine vessel dimensions. We will talk about deionizer regeneration chemicals and how to calculate the amount of chemicals required, which is required for efficient regeneration. Then we will discuss the design considerations for vessels, control system, type of control system, and we will take some examples for the popular and common controlling systems in the market. In the section concerned to reverse osmosis and nanofiltration system design, we will explain the process mechanism and the principles and what the most important expressions and key terms related to reverse osmosis and nanofiltration are, such like recovery, flux, reject, permeate, and salt rejection. We will also talk about factors controlling reverse osmosis and nanofiltration design like temperature, TDS, and water source. Also, we will talk about the required pre-treatment for reverse osmosis or nanofiltration systems like filtrations with all types, iron and manganese removal, softening, disinfection, chlorination and dechlorination, and chemical injection. We will learn what the fouling and scaling are and what the types of scales and fouling that could happen in membrane system. And we will talk about scaling calculations and control and fouling prevention techniques. Then we will learn how to design reverse osmosis module, how to choose the suitable membrane for your application, how many membranes you need, the arrangement, how many trains, how many stages or passes. Also, we will learn how to design double-stage reverse osmosis and two passes reverse osmosis system, and when we use each type of them. Further, we will talk about other parts in reverse osmosis and nanofiltration system like high pressure pump or HPP, pressure vessels, control system, and instrumentation. At this point, we will be finished, and I wish this course will be more than satisfying to your expectations, and thank you.